Hi everybody, this is the first video in the Unit 10. Unit 10 is going to talk about triangle congruence. So we're going to start off talking about classifying triangles, different kinds of triangles. So let's get started on 10.1. We are going to be classifying triangles and their angles. That just means like saying what kind they are. So equiangular, the word equiangular means that all angles are congruent. You can see that root word of angle is in there, equiangular. So equiangular is all angles are congruent, whereas equilateral means that all sides are congruent. So equiangular is angles, equilateral is sides. Then also with the angles, we can talk about an acute triangle. An acute triangle means all the angles are acute. That's less than 90 degrees. Or we can have a right triangle, or we have one which is a right angle, and a right angle is 90 degrees. And we can have an obtuse triangle. An obtuse triangle is one that has an angle that is greater than 90. Okay, then we talk about sides. So I mentioned equilateral. There's also isosceles, which means that two sides are congruent, and then scalene, which means that no sides are congruent. So when we talk about congruence, we look at a couple things. We look at the numbers, obviously, and then we also look at the markings. And remember that these little hash marks means that those are congruent. So we just keep that in mind. So we're going to look at these three, talking about the angles and the sides. So starting off with the angles, because all the angles are measured, our options are on angles are equiangular, or acute, or right, or obtuse. So if we look at this, all of these are acute. So this is an acute triangle because of the angles. And the other thing is there are no markings. Remember I said that these markings mean they're congruent? There are no markings like that. So since there are no markings, it's either equilateral, isosceles, or scalene. Well, it must be scalene because it says none are congruent. So this is an acute scalene triangle. On the next one, if we look at the angles, well, I see one angle here that's greater than 90. If it's greater than 90, this must be an obtuse triangle. And then the other thing is we go by the sides. And again, two of them are marked. So if two of them are marked, that's isosceles. And then the last one, we see that the angles are marked. And so those are equiangular. And then they didn't mark any of the sides, but something that is true is that equiangular and equilateral, they go together. If one is equiangular, then it must also be equilateral. And we will actually get to that in 10.3, but it is true. So just so you know, if it's equiangular, it is also equilateral. All right, here we have a triangle. It says 6, 8, and 10. Those are the side lengths. We don't know anything about the angles except for this one. And that little square in the corner means that it is a right angle. Okay, it says explain why the triangle is scalene and right. Well, it's scalene because no sides are congruent. And remember that little wavy over an equal sign? That means congruent. So that means no sides are congruent. And it's right because angle L is a right angle. And that little mark there, that tells us that that's a right angle. Okay, in your booklet, it starts to get, the formatting got messed up on these pages. So we're just going to try to pay attention to what I have on my screen and find out where that is on yours. Like this one up here, this had like a line going through it, so ignore that line. That was just, I don't know, the formatting got messed up, so sorry about that. We talk about angles. We can talk about interior angles, and the word interior means inside, and the word exterior means outside. So if we talk about interior angles, those are the angles inside the triangle. So this is interior, this is interior, and this is interior. And the exterior angles are angles formed by extending the sides of the triangle. So if I draw this line and I keep going, then this is the exterior angle. Same thing over here. This is the exterior angle. And over here, man, it's kind of hard to see. It's going to be this one up here is the exterior angle. And I was saying it's hard to see because what you look at the angle, and then you look at the line that kind of creates that angle and keep going out, and that's where that N is there. So the exterior angles are outside, the interior angles obviously are inside. Now, I have to turn my page, but this is on your first page. It got bumped. So the triangle angle sum theorem says that the sum of the measures of the triangle adds up to 180. So you can write that there on page 43. And once you get that written down, then go ahead and turn your page. Okay, this says that all angles add up to 180. So in other words, if I go to my diagram, I should be able to say, I'm going to call this X just for, we have to call it something, so I'll call it X. And this says that 47 degrees plus 62 degrees plus X degrees should add up to 180 degrees. That's how it works. So now if I go to my calculator and I add those two numbers together, I get 119 over here. And remember that what I'm doing is, on solving my equation, if they're on the same side, then you add them together. So we just add those together, we get 119. Okay, now we have 119 plus X is equal to 180. I need to solve for X. So I'm going to subtract 119. And when I do that, I get 61. So X is 61 degrees. That's how you do it with equations. Some of you might just be better at kind of like doing it without an equation. And what I mean is you would just add these two together and subtract from 180, and that's how you find the X. So if you add 57 plus 62 and subtract from 180, it's going to give you your answer, and that answer would also be 61. All right, example B. This one, I can tell by looking at it, that's going to be obtuse. This angle should be greater than 90 degrees. The way we set it up is we add them, and once again, I called this one down here X. So I add these together, that gives me 52, and I subtract that from 180, and I get X equals 128. Okay, this next one is kind of tricky. We have to do a couple of different steps to get there. I think it's kind of fun because it's like a little challenge. So first of all, I'm going to call this one X. I need to find X. Let's focus on that one first. So I'm going to add up my 45 plus 85 plus X. All that added together will equal 180. Well, 45 plus 185 is, 45 plus 85 is 130. So if I subtract that over, then I get 150. Sorry, just 50, not 150. So this is 50 degrees. Now the next thing is, I need to figure out over here. But in order to get over there, what I'm going to do is look at this line. Remember, a line adds up to 180? And so what I have here is I have the 50 from this. I have the 80 over here. I need to find this. I'm going to call this Y. So I'm going to say that 50 plus 80 plus Y adds up to 180. All right, now you might be thinking, how'd you get 180? Because 180 is supposed to be a triangle, right? But it's also a line. 180 is a line. So I add these up, and they should add up to 180. Okay, 50 plus 80 is 130. And so now I'm going to subtract that 130 again. Now, very coincidentally, this is a coincidence. It doesn't always happen this way. Sorry, that was a 130. This comes out to be 50 degrees, which is coincidentally what it was over here. Does not always act that way, but it happens that way here. And then lastly, I need to come up with this one. I might call that Z because I'm running out of letters. So I'm going to call that Z. I'm going to say, okay, now I have a triangle, and a triangle is supposed to add up to 180. So 50 plus 70 plus Z is equal to 180. And 50 plus 70 is 120. So that's a Z. When I subtract my 120, I get Z equals 60 degrees. So this one is 60 degrees. Now it only asked for, that was the only one it asked for, but we had to do all that work to get there. So we had to kind of jump around to get to there. But that is my final answer. Letter E is similar in that it's like missing information, but it has a different setup. And so let's just talk about how to do this one. First on this one, I'm going to find this piece here. And so I start off with 25 plus 55. And then I add my X, and I say all that adds up to 180. Well, 25 plus 55 is 80. And so, I'm sorry, that's an X. So I have 80 plus X equals 180. I subtract my 80, and I get X equals 100. All right, that's 100. Now, do you remember what's going on here? We have this angle, and they're like pointing at each other like that. That means that they're congruent because those are vertical angles. So if those are vertical angles, if this is 100 on this side, it must be 100 also on this side. So now I can solve for the other one that I'm actually looking for, and I'll call that y again. So I can say, okay, now I'm in this triangle on the bottom, and the bottom triangle I have 100 and a 22, and of course y, I don't know what y is yet. So this comes out to be 122 plus y, and so I take 180 minus 122 to get my answer. And that's going to be 58 degrees. So sometimes you might have to kind of jump around to get to the answer you need. Okay, then we get into some that are going to require a little bit more algebra, a little bit more equations. Not too much though. We're going to add all these three up, and what should we set it equal to when we add them all up? They equal 180, don't they? Just like all the other ones have. It's just there's like more going on. There's more x's. But it's not too bad. So I set them all on the same side. All those add up to 180. Since they're on the same side of the equal sign, I'm going to combine my like terms. What are my like terms? Well, 76 and 4, those go together. So those add up to 80. And 11x and 14x, those go together. That adds up to 25x. And of course, I have my 180 on the right. I need to now solve my equation. So now I'm done combining like terms. I need to subtract from both sides. So I get 25x is equal to 100. I divide by 25, and I'm running out of space here. So I'm going to come over here and just say x is 4, because 100 divided by 25 is 4. Now we could plug it back in and check it. I'm not going to take the time to do that, but if you get stuck, always do that. Plug it back in to check it. All right, this next example, it appears to have something missing. However, remember that this is a right angle. That little square means right angle, and that means a 90. So now I have all three angles, and I can add those three together. So I have my 90 that I just talked about. I have my x plus 19, and I have my 5x plus 5. And all those added together to be 180. Okay, once again, I need to combine my like terms. So 90 and 19 and 5. I'm going to put that into my calculator and see what I get when I add up 90 plus 19 plus 5. That looks like 114. Then I'm going to add my x's. My x and my 5x add up to be a 6x. So now I have that equation. I need to subtract my 114 from both sides. And so I get 6x equals 66, divide by 6, and I get 11 as my answer for x. And again, we could plug that in and make sure it adds up. The only thing new about this one is there's no diagram. But that's okay, we can do it anyway, because what we've learned is if we add all three of them together, they should add up to 180 degrees. So I'm going to do that. I'm going to add these together, set it equal to 180, and now I'm going to solve it. To solve it, because all this is on the same side, I'm going to add my like terms. So in other words, 6x plus 3x plus 5x. If I add all those together, I get 14x. And now I'm going to go to my numbers. I have an 11, I have a 2, and a minus 1. So that's 13 minus 1 is 12. I'm solving for x. I'm going to subtract my 12 from both sides. I get 14x is equal to 168. I go to my calculator. I take 168 and divide by 14. My calculator says that x is 12. Okay, so we get x is 12, but now it's asking for all the other stuff. Well, okay, I found this one, x is 12, got that. Now what I need to do is I need to plug that back in and see what I get. So in other words, I'm going to take 6 times 12 plus 11. I'm going to do that on my calculator, and I'm getting 83 on that one. Okay, same thing for this. I need to take 12 and plug it in for my b here, so that's going to be 3 times 12 plus 2. I work that out. That is 38. And for c, similarly, I'm going to plug in the 12. So 5x minus 1, 5 times 12 minus 1, put that in my calculator. When I put that in my calculator, I get 59. Now, I was mentioning checking it a minute ago, and I feel like this one has enough going on that we probably ought to check this. What we're going to do is we're going to take 83 plus 38 plus 59, and we can do it on our calculator, and we're going to see, does that add up to 180? And I put it into my calculator, and yes, it does add up to 180. Now, you might be wondering, why didn't I put in the 12? Well, I did put in the 12 into all of these. And so that's not actually an angle, that's just x. These are the angles. And the angles do add up to 180, so we are good to go.